Hello SSG followers, YouTube followers and other followers. Okay, we finally here. 20 charging procedure should happen. And let me show you my equipment. First of all, I should put this on record. This is not another Unity system, because the way how I charge my primary battery, it is very conventional way. I charge this 12 volt 5 mAh battery by the normal current which I get from the conventional socket from my wall. So this is a conventional charged battery. Okay, and then my equipment. What have we here? Today on this side you see my charging battery. This battery was previously discharged with 250 milliamps to the voltage level like 11.16. Now look at the resting voltage. The resting voltage is 12.04. Okay, next device. Next device, it's a milliampere, which measuring the amount of milliamps which is going to my charging battery. But I put this on record. I do not charge my battery by current. I charge my battery by very fast and high powerful impulses. Next device. Next device is a voltmeter. It measuring the voltage of the current which going through all of these lamps. It's like minus and plus connected between lamp connection. So pretty simple. Next measurement equipment. Okay. Now you see the voltage of my primary battery, the same type and quality of the battery which I have on other side. It's a 12 volt 5 mAh battery, charged as I said conventionally. Previously 20 hours charge. I use conventional device with current like 300 milliamps to charge this battery, and I charge this battery for about 20 hours conventionally. And this is the voltage of my conventionally charged battery, 12.49 volts. Okay, this is the milliamps. This milliampere showing amount of current which I use to run the system. Okay, next to my oscilloscope. This oscilloscope connected probe to the emitter and probe ground to the collector. And this is the picture. The system is not started. I need to switch on my system like this. System is switched on. Now I move the wheel. So it's not self-running system. You need to put additional initial force with the hand, like this. Okay. Wheel is moving. I put initial force to move the wheel. Now observe the values of my voltage of charging battery and milliamps of my charging battery. So as you can see, I have here 15 milliamps which going to the charging battery, and the voltage level of my charging battery is increasing. It takes time. I will hold the camera until I see the point where it's 12.10. Yeah, here you go. And then it's not rapid charge as you saw when you use when you use conventional charging devices. you always see the immediate high voltage rate when you charge your battery, but in this type of system you don't see high voltage rates of the system. So it's charging, but it's slow charging process, but it's a very very high quality charging procedure. So, and this is the milliamps which I'm getting from my system. Okay, next you see I observe the voltage which is going through all of these lamps. The lamps connected are in parallel, minus plus minus plus. So, and this is a voltage which I'm getting on these lamps, and the lamps is not light on because the high spikes, high impulses which I getting from my system, they are very fast, and they are getting through all of the circuitry, to my charging battery, and you can clearly see that I'm getting charge, that my battery getting charge to charge itself from my circuitry. But I put this on record. This is not on our Unity system because it took me some energy to charge my primary battery. Okay, now I will show you my primary side. You see here the voltage 12.40, so it's stable voltage. Amount of current which I spent to run the system, it's like now 29-30 milliamps. Okay, now I see initially when I first moved the wheel, it ran on 14 or 13 milliamps, but currently it's a little bit lower, and it should get a little lower than this. It should run on 28 milliamps. Maybe if I hold the camera longer, you see this. Anyway, I promise you to show my movement of my wheel. So here you go. I put my laser on the wheel and just hold the laser on the wheel like this, and we will get some value. But anyway, I'm not sure this is accurate values which you are currently seeing, and it's not so good tachometer which I currently hold in my hand. It calculates the average of movement of my wheel. Okay, I think it's enough. Now let's look what we got on the measurement. Probably 55 RPMs currently, and from my observation it's probably the accurate value, 55. So here you go. As you can see, my system, my primary battery voltage did lowered a little bit because it has load on himself. This is actual this is another proof this is not another Unity system, because I'm losing on one side the energy, but still on the other side I getting my battery charged, and this is what is important for me. I'm doing some work, and with work the way, I mean, I produce with my work additional energy which can be caught, and this energy goes to charge another battery, same quality, same manufacturer, but it actually charging my battery with this type of voltage which I am currently getting from my system. But this is not an opportunity, because in ideal situation I need to have a system where I can produce energy, and then when I got this energy, I should put this energy for production a new additional energy source, and then this additional energy source will sustain the first energy source. So it's not so easy to explain. It's my understanding of how our unity should work, but I clearly not having this situation, and I cannot claim an unity with my system, and I put this on my record. But still, I get the result. I get fully charged battery. I calculate. I did discharge my battery previously. It was like 10 hours, and it's probably good to say I still not getting the full capacity of my battery, which I charge with Bedini system. But I see some strong rise in difference from charge to discharge, from discharge to charge, and I see that the battery behave better. It takes longer to discharge the battery. So in any observation I see only the grow, how long I can discharge the battery. So I just need to push the battery with my impulses further. And this is what I spoke in my previous videos. You cannot get fast charge with this type of system. Maybe in only one situation, if you got a lot of transistors which working synchronous to each other, and when you have such system, you should probably get faster results. But it always depends on the quality of chemistry and quality of the plates of the battery. So do not complain about this if you use wrong batteries and if you produce not enough impulses to charge the battery appropriately. So anyway, let's look at the oscilloscope. Let's look at the oscilloscope. Probably I need to get even closer. Okay, let me make a shadow. This is a currently I don't have my laser pointer, but you clearly can see amount of spikes which I'm getting here. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13, 14, 15, 16, 17, and 18. Okay, and this is the spikes which I'm getting here, and they're positioned at the middle, almost at the middle of the device. But you see, it's very strong and powerful impulses, and these impulses I get only when the circuit, SSG Bedini circuit, is connected to my charging battery. So what I actually want to try, and I showed this many times, I disconnect the charging battery from my circuitry, like this. Immediately you see the bulbs are lighting on, and you see the voltage. Probably not seeing good. Just let me good zoom on it. It's wrong. I know. Wait a second. Probably this is good. And this is I'm getting when all. So voltage level is the same as it was in the previously 11.95. Oh, now it's, you see better, 11.86. So question is, voltage beta cannot show the accurate values with impulses which I'm getting here, because all these lights, all those neon lights, the neon lamps which you are actually seeing here, they are work only on 230 volts level. So here is a proof that I'm getting the impulses, and this impulses has real energy, because this all lamps pretty bright, and this is a amount of milliamps when the system is not hooked up to the charging battery. Okay, so once again, these bulbs, these neon lamps are needed to protect the system for overcharging, or for high, very high voltage, which I'm currently getting here. But this is not this is not the way. This is not standard impulses which you can get with some other devices. So once again, I claim this is not standard impulses which you can observe in your conventional impulse charging device. Look at the values of the voltage. It's like 1195. So here you go. You see 12.12 on my charging battery, milliamps nothing. So I need to, I almost forgotten to show you my oscilloscope when the system running in such type. You clearly and immediately see the impulses which I'm getting on the system. And I have another idea. Let's measure the RPMs on my wheel. It's probably interesting too. Now it's not so accurate at first. It needs to calculate the average of the wheel moving. So I hold like this. Hold it. Not showing some real values, but let's look once again. And 66 probably. Decide for yourself. So anyway, not charging here because I did not hook up my circuitry. You clearly see this 000, no current, no voltage getting to my battery, but the protection working, this bulbs working, and you see here clearly it's 1186 volts voltage which go through these lamps. But these lamps even they show even larger energy, but I cannot measure with my voltage meter, standard voltage meter. So once again, back to my oscilloscope. What I need to let me, okay, maybe I can bring this to the proper picture. Okay, what I'm just adjusting volts per division. It was like, first of all, it was like 0.5 volts. I can switch it on the mode 5 volt per division, but I need to do some time variation. It's difficult. It's very difficult, and it's not simple. Okay, let me try actually 2 volts. 2 volts per division. This is time variable. It's very quick. It's too quick for my device. Maybe now I'm adjusted to 1 volts per division. Let me try to do the picture. Let's see, right. So it's a lot of impulses I'm getting, and when I do other thing, now it's showing me 0.5. Probably I should work with 5 because then it's better. So probably I should put my oscilloscope so that I can get my shadow on it, and then you have better picture. So I'm getting a lot of impulses, and you can count yourself how large it is, but it's clearly very powerful voltage impulses from my observation. Maybe if I move the level. Okay, now I have something. Now probably okay, so you clearly see that I'm getting, oops, it's not the way, I need horizontal. So it's actually values on 1 volts per division. Let me put on 1 volts per division. So it's a lot of spikes which I'm getting here. You can count for yourself what time. Just need to time variation. Time variation, it's not so always so good, but in any rate. And when I try to adjust vertical position, not so good. And intensity not the way. Okay, it's just sharpness. So you see for yourself that I'm getting a lot of impulses. And let me count. Let me first check if I can put all. Okay, when I do like this, so now I actually have here. So I just count the impulses: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 maybe. So a lot of impulses, high rapid voltage impulses, and this is probably the reason why I cannot. This is probably a reason why I cannot code them on my voltage meter. You can actually tell that I'm having here. I just set up 200 volts. Let me out of zoom. Sorry, just after zoom. Need to. Camera goes crazy. And now I just need to. Okay, now probably okay. Sorry guys. So I'm just switch it to the 200 volts, and it showed me 11.8. So if somebody say I'm getting here actually AC current, so AC voltage don't show anything. AC voltage showing anything. 200. 600. So now AC voltage, it's only possible to measure at level of the DC voltage, and this is what I'm getting with my Bedini. So, and in the conclusion of all of my charging and discharging experiments, I conclude following. You need to set up system where you have less current consumption and more high voltage impulses, and these impulses can be observed with a traditional measurement equipment like this oscilloscope. Maybe it will be better if I got the digital device. Maybe if I can buy me just USB system where I can show you digitalized build. But I do not wish to do that because I don't need to prove anything. You seeing the proof onto the camera right now. What you need more? Just build the experiment like Bedini tell you. Use proper charging and discharging procedure onto your battery. Do not, I repeat, do not mix up a conventional charging procedure with a non-conventional. And what I mean by that, you charge one battery. You charge the one battery always with a Bedini. You do this, then discharge the battery maximum to the 11 volts. I know it can be sometimes difficult because at first you cannot get the 20 hours discharge, and I say from all of my observations this is a normal behavior of the battery, but I should put additional information and say this is what I observe onto the one transistor system, because you can see 7 or 10 or and I don't know, even more transistor system. For one transistor system, you need to actually, to get to see some results, you need to produce so much of impulses. And now what I do is show it all. I connect my charging battery. You see clearly here the voltage of my battery is decreased because it wasn't charged to full capacity. So when I hook up my connection from my ECG circuit to the battery, I immediately see the milliamps and the voltage increase, and it's getting the voltage increase, and I see the current. So and it charge my battery. It takes sometimes longer than 20 hours, sure, but I got always full sign of the fully charged battery. My last discharge procedure, when I discharged my battery, did not show me the 20 hours of the discharge, but it was like 10 hours. And if you can calculate to 0.250 milliamps multiply with 10 hours, so like this, 2.5 amps. But anyway, I'm interested to get the battery to the charge level. And the time when the battery is fully charged, it's like 13 or 15 volts in the best case. In the normally it should be always 12.65 volts of fully charged battery. So you saw this in my previous video, and I'm pretty sure it will happen this time. But here you go. Here you have 20 20 charging procedures. And for the future, people who are actually do not build the system, what I can tell you how to do this, how to build the system best. You need to wind the coil. You need to wind the coil counterclockwise. Yes, then it will. Then the system will work in attraction mode. It even powerful than repulsion mode, and my system running in the repulsion mode because I wind my coil clockwise. So, in any rate, I see in the results. I'm pretty happy with the result, and I can claim following: if you take an impulse charging device, conventional impulse charging device, and say you want to compare my build of the SSG circuit and the conventional impulse device, you would probably see difference, because look onto the amount of current which I put to run my system. This will be on the conventional impulse charging device high value, higher than what I'm getting here. So you need to build the system to understand actually how it works, why it works, and how you can use the energy. And by any means, this is not another Unity system. Come on, people. You need to charge the battery somehow. Maybe if you tell me, okay, we can charge your battery, the primary battery, with the solar panels. This is for free. Okay, you have maybe the case. But I charge my battery, my primary battery, I charge it always conventionally. I'm taking the real power. I'm paying for this power for the power to the power company. So this is not an overheating system, because I do not use this energy to run this battery. I don't do this. I'm just getting the energy, enough energy to charge all the battery. But as a result, my primary battery discharge, and you see this. It's clearly, it started with 12.43 volts, and now it's 12.36. So not an overheating system, but still very clever and very efficient way to charge your batteries. And don't forget, I can build one apparatus. I know this because I saw this from the videos of other people. I can build the apparatus which actually would consist of additional trigger coils. These trigger coils can be connected to the condensators, capacitors, Kondensatoren, we Germans say, but I'm actually not doing this because I do not have time for doing this. I'm just looking at the current result. But when I'm done with my charging procedures, I can look further and far away from all what I'm here doing. So just think what you can do next if you get my results which I'm getting here. Yes, I can build pickup coil, trigger coil. This trigger coil will be separate system. It will collect the collapse, these impulses which I am producing here mechanically, so to speak. And this coil will charge capacitors, but I need to build such coil to prove something. This is more in theory what I'm actually right now speaking about. So you can build a coil, you can take the energy from this coil, charge your capacitors, and then discharge the capacitors and put them into the primary. And primary can be a capacitor, but I did not test it yet. So it should be tested and then decided of if is this efficient or if it not. What I actually can claim currently, that I am charging my battery by very powerful high voltage impulses. And by all means, I mean, this is what charging my battery, not something else, not the current. So if you not trust me, just build the system how Bedini tells you. Do not mix up your battery. So do not, how to say, do not expect quick results. You need to put your battery through some charge and discharge procedures, and only after 19 or 20 charging procedure you will see some results, not sooner. But this is only for one transistor system. If you got 3, 5, 6 more transistor system, it will be different, because each transistor can produce enough impulses to charge your battery faster and with more capacity, so to speak. But I do not have this situation set up on my system, so think about this through and hopefully you will get the results. But for me, what I can promise to show you next, I will show you the end of my charging procedure number 20, and then let me show you something interesting. Probably it will be a spontaneous idea, but people love to see some pictures. No, okay. Now let me show you some more interesting stuff. It's sorry for the I was not prepared to show you, but it was like spontaneous idea. So let me put this on the light. Oops. So okay. I'm not sure. Let me put the camera onto the wheel and work this through. So like this. Okay, now let's think this through. So you actually seeing this is my inverter. This inverter works on 250 milliamps and 12 volt voltage. This is a conventional device for charging of battery. Maybe if you see the values. So what I should do after 20 charging and discharging procedures? I will hook up this inverter to my battery, which I previously charged with the Bedini, and then to this inverter I hook up this DC conventional charging device and charge my primary battery. And if I do this many times, you can decide for yourself. I will show you some of these charging procedures because they are pretty trivial, because yeah, as I said earlier, it's pretty trivial stuff. But anyway, you clearly see that I'm charging my battery with these short impulses, and it is actually possible to charge your battery. So, and if this is not enough for you, I saw some people even from foreign country, like for example from Ukraine. Some guy, what he done, he put under the axis, he put aluminium tube, and then he put a AC motor generator. So he produced AC current from the mechanical movement of the wheel. I'm actually do not recommend this, because when you generate AC current with this type of mechanical work, you produce counter forces, and these counter forces can stop producing the impulses. So you can do this, but I'm not sure it's efficient for this type of the system, because it's not a generator in conventional thinking. This is not a generator type system. This is not when you run some motor produced mechanical work, and then mechanical work, how this, as a result of this all mechanical work, you run some coil and you produce the current. This is not the way. I just try to explain what I'm thinking about the system. You put the current onto a SSG circuit. This current goes to the coil. Coil produce electromagnetic pole. This pole is opposite of the north pole. Remember, all of magnets are north pole positioned. Each magnet looking with the north pole to the coil. So what happens when two magnets see each other? They repel themselves. But then, for the short time, you have another pole which takes another magnet, and so on. This is how the wheel moving. Then, actually, each time when the magnet passing through the coil, some collapse of the coil happens, and the transistor close one of the pathways in the circuitry, and when he close the pathway in the circuitry, this energy which suddenly appears in the circuitry, it goes to the charging battery. And this is the energy which you actually see on my device. This is actually these impulses. You can probably say this is energy what you get for free, but you cannot use this energy conventionally. You need to transform this energy to some proper way. And some proper way will be a capacitor, hook up a capacitor, or hook up a battery. With a capacitor you probably get even faster results, but you should watch out. Capacitor cannot sustain a lot of volts. It can explode, so be careful. But for the normal battery it should work pretty well. For this type of the battery which I have here, you can use this type of the batteries, but I do not recommend. Sealed lead acid batteries do not produce good results. So do not use them, because, as I said earlier, water just vaporizes, and you cannot add water. You can add water, but it won't get to the chemical process which you need. So it's sealed lead acid batteries do not suit for this type of experiment. But the batteries where you can actually put the distilled water, so it should be technologically possible to add the distilled water to the battery. This battery is actually pretty good for this type of experiment. This is one of the important things which probably people forget when they building such system. So you need, I repeat, you need to use batteries where actually was thought engineered to fill up the battery with the distilled water. This is prerequisite. It's a prerequirement to have such property. And next important thing, it's a transistor. I did show earlier the transistor which I saw a lot. I saw this a lot, and let me have this transistor once again. Let me have it. Oh, come on. Okay. I saw a lot of people running such transistor. Okay, my first initial experiments, I use this transistor too. It's cheaper than MGL transistor, but this is transistor which cannot work at the high frequency, and how should put this right way. The rules of the game to actually work with pretty fast and very quality transistor. So this transistor which I am currently showing you, it can be used, but you won't get the results which I currently getting from my system. So you can use this, but I do not recommend, because it's not very efficient. And MGL transistors are the best transistors for this system. And Bedini actually used them in his larger and more powerful system. So why you should do the test with the wrong transistor, I don't know. Probably Rick Friedrich got these things very wrong, but I'm not here to criticize somebody who worked with Bedini a lot of years. But anyway, you can get the results. Battery is charging, and here is as I described, pretty conventionally from this side. So here we go. I'm running my system on 27 milliamps. Voltage of my primary battery is decreasing. Here I'm getting 11.88 volts. So this is voltage between all of these battery lamps, neon lamps. So here you go. Actual 20 charging procedure with a very good result. What I should tell, this is not another Unity system once again. And last time I will show you my wait a second, a measurement of the wheel. Okay, it got out of zoom. Sometimes it's difficult. Okay, let's look. I have 33 RPMs, probably. So this is it, people. This is it. I actually done it. I'm very happy. And enjoy yourself and build the system how Bedini tells you. One thing which I probably give as my last advice when you build the system. You see all of this coil wire which I'm using in my circuitry. At first I used different wire, and this got me sometimes self-oscillation mode of the circuitry. And you saw this many times. I disconnected one of the connections from the primary battery, and now I'm currently full. You should, when you build this system, you should, when you use the wire, you should try to use the same wire which you have in your coil. So use the same wire which you use in your coil, and then you will get even better results. I would say it will be more powerful system probably, because you don't have the because you have no impedance, no difference in impedance between your coil and your circuitry. But anyway, this is it for me. 20 charging procedure. If you like to advise me something, I'm not currently at the position to take any of the advice from the people who not prove me somebody. So if you want to give me some actual real good advice, you should prove me that you built this system, that is you running such type of system, and that you have experience with such type of system, and then I can take your advice for granted. But if you don't have such system, you don't know how the system runs, you don't have knowledge about the batteries, and I just ignore or just comment very poorly your comment. So don't do this. Just think all of things through, and if you're not sure, just ask me simple question about how to build this system, what is important about build, and how you can do this better, because you can actually build a larger system with a better quality and better power production. But one of the important things, once again, I disconnect the system from the charging battery. Lamps goes on. Power consumption from the primary battery is increased, and I got such impulses. So if you do this right, you should get such results, or even better. Okay, so this is all for me, and I hope you have learned a lot, and see you soon in the internet. Bye bye.